So first off, for this one, all we need to do is sketch the slope field for part A. So slope field should have been pretty straightforward. Really, you've only got 6 points, so you might as well just plug each point in and see what you get. So if you plug in 0, 1, that should give you -1. If you plug in 0, 2, that should give you -2. If you plug in 0, -1, that should give you +1. Plug in 1, 1, ought to give you 1. Plugging in 1, 2 ought to give you 0, and plugging in 1, -1 ought to give you 3. So that's what your slope field should look like. That was worth 2 points. 1 point if you had the one where it was supposed to be 0, and 1 point for all of the rest of them. I don't know why there's that little weird mark there, but 1 point for those 5, 1 point for that one other one. Easy enough? All right, second one. Find the second derivative, so that should be easy. Second derivative ought to be 2 minus dy dx, which we would write as 2 minus 2x minus y. And we want to determine the concavity for all solution curves in second quadrant. So in the second quadrant, we're looking at -x and a positive y. So if we're looking at a -x and a positive y, then this is going to be negative, and this is going to be minus a positive. So this is going to be a negative number inside of here. So we're going to have a 2 plus a positive, if a minus a negative, or 2 minus a negative, which is for sure going to be positive. So for sure going to be greater than 0, which tells us that the concavity for all solution curves in the second quadrant is concave up. Good or no? And that was 2 points. 1 for getting the second derivative correct, and 1 for saying concave up with a reason where that second derivative was always positive in the second quadrant. Good or no? Okay. Wait. Okay, I'm waiting. Second derivative is always positive because in the second quadrant, x is negative, which makes 2x negative, and y is positive, which makes the minus y a larger negative. So 2x minus y is always negative, and we have 2 minus a negative, which is 2 plus a positive, which is always greater than 0. And if it's greater than 0, it's got to be concave up. All right, part C. We're going to let y equals f of x be the particular solution to the differential equation with the condition that f of 2 is equal to 3. We want to know, does f have a minimum or maximum at 2? So first off, or neither. First off, we need to figure out what the derivative is at the point 2, 3. So we'll evaluate dy dx at 2, 3. When x is 2 and y is 3, that is 1. And if that second derivative, if that first derivative is 1, we don't have a critical value there, which means we have neither. There's no critical value, therefore no max or min. Easy enough there for part C. All right. And then part D, find the value of the constants m and b for which y equals mx plus b is a solution. So we've got dy dx equals 2x minus y, and we want y equals mx plus b to be a solution to that differential equation. So that tells us that dy dx should be equal to the derivative of this. So this dy dx is just m. So that tells us that m should equal 2x minus y. And if we have 2x minus y equals m, we also know that since y is mx plus b, we can say that 2x minus mx plus b should be equal to m. And from there, we should be able to put everything onto one side. And if we got 2x minus mx plus minus b minus m. And if we were to factor out the x here, we have x times 2 minus m minus b minus m equals 0. And just like when we do our partial fraction decomposition stuff and we, say how many x's are there on this side? Well, there are 2 minus m x's. So 2 minus m needs to equal 0 because there are 0 x's over here. And negative b minus m also needs to equal 0 because the constant on this side is negative b minus m and the constant on this side is 0. So this tells us that m equals 2. And if m is 2, then b must be negative 2. And so that solves that system of equations and tells us that if we had the equation y equals 2x minus 2, it would solve dy dx equals 2x minus y. Good or no? We plugged in the mx plus b as the y, just so that I could get rid of all the y variables, so I could just get it down to just having an x in here. Yeah, just because I wanted to, because I had x, so I had a bunch of different unknown things. I had x, y, m, and b. But if I can get it down to just the two of them there, then that makes it a lot easier. So if I can get rid of either the x or the y, we want to do that. And yes, I can go back and re-explain part C. Part C, in order to have a relative min or a relative max, we have to have a critical value. And a critical value would tell us that the derivative must be 0 or undefined. But if we plug in the point that they're asking us about, the point 2, 3, to our derivative, we get 1. And so if the derivative is 1, we can't have a max or a min because max and a min can only occur at a critical value. Anybody else have any questions on that one? All right, let's do this one. We hadn't gone through this one yet, had we? I don't believe. So first part, find the limit as x approaches 0 of f of x plus 1 over sine x. So if I plug in 0 to this, that's going to become f of 0. And f of 0 is -1. So we got -1 plus 1, which is 0, over sine of 0, which is 0. So using Locatel's rule, we'll make this the limit as x approaches 0 of f prime of x over cosine of x. And f prime at 0, we'll have to figure out what that is by plugging in 0 for x and -1 for y. So dy dx at 0, -1 should be 1 times 0 plus 2. So that should be 2. And then over the cosine of 0, which is 1. So we should get 2. Everybody good there with A? All right, part B, using Euler's method, starting at x equals 0, 2 steps of equal size, we want to approximate f of 1/2. So if we're going to go from 0 to 1/2, we're going to do 2 equal steps of a quarter. And so first off, we will write out our first point, which was 0, -1. We know that our change in x is going to be a quarter. We need to figure out the value of dy dx. So dy dx at 0, -1, we already figured out to be 2. So we're going to have to multiply that by 1/4, and that should give us our change in the y value, which should be 1/2. And so we should end up at the new point 1/4, and then -1 plus 1/2, which would be -1/2. Everybody good with the first half of that? Hopefully. Okay. And then the second part of that, since we're starting at 1/4, -1/2, we'll need to figure out what our value of our derivative is at that point. So y squared ought to be 1/4. And then 2 times a fourth ought to be 1/2, plus the 2 ought to be 5/2. So it looks like that gives us 5/8. And we got to multiply that by 1/4, which ought to be 5/32. And so our value ends up being 1/2, and then -1/2 plus 5/32. So that's -16/32 plus 5 ought to be -11/32. And so your answer would be -11/32. Everybody good there with that? Any questions on that part? All right. Part C, find a particular solution. So the y squared and 2x plus 2. Okay. Given the 0, negative, now I forgot, 0, -1? Yeah, 0, -1. So this is just a separation of variables. Dy over y squared equals 2x plus 2 dx. Integral of y to the -2 is -1 over y equals x squared plus 2x plus your constant. Plug in your initial condition to get your constant of 1. There's our constant of 1. So we'll go back in, -1 over y equals x squared plus 2x plus 1. And we'll just take our reciprocal and divide by negative. So y equals -1 over x squared plus 2x plus 1. And that's your answer. That last part was actually worth 5 points, 1 for separating the variables, 1 for your correct antiderivatives, 1 for even having a constant, 1 for using the initial condition to find the constant, and 1 for getting the final answer. Both of these were worth 2 points each. So 1 for the first step, 1 for the second step, 1 for using Locatel's rule, and 1 for getting the right answer. Any questions there on that? So they don't ever ask for the interval of validity. Technically, for this, you would find the interval of validity, and you'd say this is, this has a discontinuity at -1, and so, but only at -1. So your interval of validity here would be -1 to infinity, because that includes 0. If my initial condition had been like -5, then I'd have to do the interval from -infinity to -1. Since this falls between -1 and infinity, then I choose out. Any other questions on that one? All right, let's see here. Did I ask you guys? I don't even remember what I asked you guys to do now. Okay, I asked you to do like the next 4, huh? But I think I said like, oh, just go over questions you might have, and questions specifically asked to find. Okay, so if they specifically want to know the domain for which it was valid or the interval of validity, they will specifically ask you for it. They do not take off points if you don't put the interval of validity, so you don't need to find it. Now, in general, with differential equations, you should be able to find it and know what it is, but the College Board doesn't require you to put it unless they specifically ask, which I've seen them do once ever, and that was like 20 years ago. So wouldn't be too concerned about them asking. So we didn't do the baby bird problem here, but I talked to you guys about doing this one, right? Doing 7, 8, 9, 10. Does that sound right? I think. Yeah. All right. So was the baby bird problem okay? Not too bad. Is it gaining weight faster when it's 40 grams or when it's 70 grams? Well, the rate at which it's gaining weight is dB dt. So just plug in 40 and plug in 70. dB dt at 40 ought to be 12. And dB dt at 70 ought to be 6. So it must be gaining weight faster when it's 40 grams. Good or no? Should have been pretty straightforward. Part B, find the second derivative. So that ought to be 1/5 times negative dB dt, derivative of 100 minus b, right? Negative dB dt. So we've now got negative 1/5 times 1/5 of 100 minus b. And this is for all b values less than 100, which is what we're looking at on the graph. For b less than 100, this is greater than, sorry, it's less than 0. The second derivative is less than 0. The second derivative is less than 0. Should always be concave down, but part of this is concave up. So you know it could not resemble this graph because a portion of the graph is concave up, yet the second derivative indicates that the function should always be concave down. Good or no? All right, then part C, separation of variables to solve. So we've got dB over 100 minus b when you separate the variables equals 1/5 dt. And then this becomes negative natural log absolute value of 100 minus b when you integrate that with your u sub. And then 1/5 t plus your constant. I believe the initial condition was that b of 0 was 20. Is that right? Yeah. So if t is 0, we end up with negative natural log of 80 over here as our constant. So negative natural log absolute value of 100 minus b equals 1/5 t minus ln 80. Divide everything by negative first. So this will become natural log absolute value of 100 minus b equals natural log 80 minus 150. Exponentiate both sides. E to the ln 80 minus 150 should just become 80 e to the negative 150. Clearing out the absolute value because we know that the value of 100 minus the weight is always going to be positive. We don't need to worry about positive or negative here. It's just going to be positive. And so we should get b equals 100 minus 80 e to the negative 150. Good or no? Any questions on that one? All right. This one is very, very similar to the last one. So using the line tangent to the graph of w at t equals 0, we want to approximate the value at t equals 1/4 after 3 months. So to use a tangent line, we need to write the tangent line equation, which means we need a point, which we have. The point should be 0, 1400. And we need a slope. Our slope should be the value of this at t equals 0, which will be dw dt equals 1/25 of 1400 minus 300. What is that? 44. 1100 over 25 should be 44. So we should end up with y minus 1400 equals 44 times x minus 0. And, or not x, but t minus 0. Sorry. And we want to evaluate that at t equals 1/4. And at t equals 1/4, that would be 1411. 44 is 11. Good or no? Okay, then find the second derivative. So second derivative of this ought to be a constant times dw dt, or just 1/625 of w minus 300. And since we know that the w value is always greater than 300, we can say that this is always greater than 0. And if you have a function that's concave up and you use a tangent line to approximate it, the value you get from your tangent line will always be less than the true value. So we'll say our approximate is an underestimate. Because it's concave up. Good or no? All right, and then the last part there is just asking us to solve that differential equation, which should be almost identical to the last problem we did. We'll end up with dw over w minus 300 equals 1/25 dt, right? Is that what we had? 1/25 and w minus 300. Yep. So this just becomes natural log absolute value w minus 300 equals 1/25 t plus our constant. Our initial condition was that when t equals 0, w equals 1400. So we end up with a constant of natural log of 1100. exponential says. And obviously we choose the positive when we clear off the absolute value, because we're not going to do 300 minus 1100 to get anything. I mean, that doesn't give us 1400. We need a plus there. So it's just W equals 300 plus 1100 e to the 125th t. Good or not? Any questions or issues there? All right. Let's see, we got time here. Okay. First off, we're going to use Euler's method, starting at 1, 2 steps of equal size to approximate f of 0. So we're going to go to the left this time instead of to the right. So let's see here. Our value at x equals 1 was 0. So dy dx at x equals, well, right, our first point is 1, 0. And our value of our slope there at 1, 0 is just equal to 1. And we're going to have to multiply that by negative 1/2, because we're going towards 0. So that should be negative 1/2. So our new point should be, we'll go back a half on the 1, which should be 1/2, and then down from 0 by a negative 1/2 to negative 1/2. Everybody good there with the first step? So we got 1/2, negative 1/2, and our dy dx value there ought to be 1 minus negative 1/2, which ought to be 3/2. We're going to have to multiply that by negative 1/2, which should give us negative 3/4. And so our final point there ought to be 0, and then we'll go down another 3/4 to negative 5/4. So 2 points there, 1 for the first step, 1 for the second step. Everybody good with part A? Euler's method within these differential equations, if you're lucky enough to get one, should be pretty straightforward. Just got to do the arithmetic. Okay. Part B, find this limit. So the limit as x approaches 1, so f of 1 is 0 over 0. So we're going to use Locatel's rule, which will give us a limit as x approaches 1 of f prime of x over 3x squared. And we know that f prime when x is 1, we already found that out to be 1 up there. So that should be a 1 in the numerator over 3 times 1 squared. So we should just end up getting 1/3. So 1 point for using L'Hopital's rule, 1 point for the actual value. Everybody good there? Okay. And the last part of this one, dy dx equals 1 minus y. So find the particular solution given that initial condition. So we'll just separate the variables. Dy over 1 minus y equals dx, or 1 dx. So that should give us x plus a constant over here, and negative natural log absolute value 1 minus y over here. When x is 1, y is 0, so that gives us a constant of -1. Negative ln1 is 0, so just subtract the 1. So we've got negative natural log absolute value 1 minus y equals x minus 1. Divide by the negative to get 1 minus x. Exponentiate to get absolute value 1 minus y equals e to the 1 minus x. And we'll clear off the absolute value, knowing that when we plug in 1 for x, we need to get 0 for y. And so e to the 0, if I plug in 1 for x, is 1. And if I plug in 0 for y, this is 1. So I need the positive value, not the negative value over here. So it'll be 1 minus y equals e to the 1 minus x. Add the y, subtract, and you get y equals 1 minus e to the 1 minus x. And that was worth 5 points for that part of it. 1 for separating the variables, 1 for getting the right antiderivatives, 1 for having a constant here, 1 for finding the constant, and 1 for solving for y. Everybody good there? Any questions on that? Yeah, so the absolute value part. So our initial condition was x equals 1, y equals 0, right? So when I clear off the absolute values, this becomes plus or minus. And so I just choose the right one based on this point. So if I plug in 1 for x, I get e to the 0, which is 1. So I get plus or minus 1 equals 1 minus 0. And so I got to choose the positive instead of the negative. So I just don't put anything there. Yeah, you just got to choose the one that makes it true. Does that make sense? Everyone good there? All right. Next one. Again, using Euler's method here. So our initial point is going to be -1, 2. Our value of dy dx at that point should be, let's see, if we plug in -1, that's 6 plus 2. So it looks like that comes out to be 8. And so we're going to have to multiply that 8 by our step, which is a half, which is going to give us a 4. And so we're going to go up by 4. So our new point should be -1/2 and 6. Did I do that right? Yeah. No. No. Did I do some arithmetic wrong there? Oh yeah, minus. That's why. Okay. I knew I did some arithmetic wrong because I happened to glance at the scoring guide and then I got a different value than what they had. So I didn't see my arithmetic error. Darn. Now I need an eraser. And the toolbar won't show up. So we're just going to go all the way back. dy dx is 4. There we go. So now we have 4 times 1/2, which is 2. And so that gives us -1/2, 4. And hopefully we can find a dy dx value this time without me making an arithmetic error. Although this one is more annoying. Let's see. 6 times 1/4 is 3/2, and then minus 1/4 of 4, so minus 1 ought to be 1/2. Hopefully I did that right this time. And now we have 1/2. Hopefully I did that right. Did I do that right? Yeah. Okay. Times our step of 1/2 gives us 1/4. And so our point should be 1, 4 and 1/4, or 17/4. Good there for part A?
Yes.
All right. Yep, x is 0 because I know how to write the right number. There we go, 0. Yeah, x is 0. Sorry about that. All right. We are told that at the point -1, 2, the second derivative is -12. Find the second degree Taylor polynomial for f about x equals 1. Okay, so the first thing should be 2 from f of -1 equals 2. And then the first derivative at -1 was equal to 4. So that ought to be plus 4 times x plus 1, since we're centered around -1. So it's x minus the -1 or x plus 1. And then they tell us that should be 12. So minus 12 over 2 factorial times x plus 1 squared. And we could make that minus 6 times x plus 1 squared if we wanted to, but that's it. That's the answer to part B. There's your second degree Taylor polynomial. Everybody good with that? All right, and then for part, that was worth 1 point. For part D, yeah, sorry, first question was 2 points, same as always for the Euler's method, basically. 1 point for the first step, 1 point for the second step, and then 1 point there for getting the second degree Taylor polynomial. And then this last point, this last part is worth the last 6 points. So if you are asked to separate the variables and solve a differential equation, find a particular solution, that is generally going to be worth the majority of the points. So in order to separate this one, we're going to have to factor out the x squared. So x squared times 6 minus y. And we're going to end up with dy over 6 minus y equals x squared dx. And so that becomes negative natural log absolute value 6 minus y equals x cubed over 3 plus your constant. And I don't remember, our initial condition was when x is -1, y is 2. Yeah. So negative natural log 4 equals -1/3 plus c. What a pain of a constant. 1/3 minus ln 4. Oh well. And so now we have negative natural log absolute value 6 minus y equals x cubed over 3 plus 1/3 minus ln 4. And we'll have to solve that for y. So first off, we'll clear out that negative sign there. So that's going to give us natural log absolute value 6 minus y equals negative x cubed over 3 minus 1/3 plus ln 4. And we'll exponentiate everything. Gives us 4e to the negative x cubed over 3 minus 1/3. If you want to factor out a negative 1/3 from that, you can. Clearing off the absolute value, we need to plug in our initial condition, which was, I keep forgetting, 2 -1? No, -1, 2. -1, 2. And so if I plug in -1 for x, this is going to become a 0 up here. And I'm going to get a positive 1/3 minus 1/3. So this will be e to the 0, so that's 1. So this will just become 4. So plus or minus 4. So I need the positive value of this, right? Because I have absolute value over here, and 6 minus 2 is 4. So absolute value of 4 needs to equal positive 4. So we'll just leave that as is. And then we will add the y and subtract this other thing. So y equals 6 minus 4e to the negative x cubed over 3 minus 1/3. And that's your answer. That was worth 6 points. They gave you 1 point for separating the variables, 2 points for anti-differentiating correctly, 1 point for the constant, 1 point for finding the constant, and 1 point for the final answer. Good or no? He just sent an email. Okay. All right. Well, hold on. Let's. Anybody have any questions on this? All right.